Welcome, guys. My name is Vincent Nando. I lecture mathematics at University of Nairobi School of Mathematics. So in this presentation, we are going to give two appetizers on how to calculate error in functions using the formula that we derived in the previous presentation. So here are the two appetizers. So the first appetizer says, if y is 4x power 6 minus 5x, find the percentage error in y at x equals to 1 if the error in x is 0.04. And then the second appetizer says, if f of x is a function defined by 4 cos x plus 6x, find the relative percentage error in the function f of x for x equals to 0 if the error in x is 0.005. So these two problems are not very hard to solve because we know from our previous presentation that error in a function is given by error at that particular point you want to evaluate the function multiplied by the derivative of the function at that particular point. So the error in the function equals to error at a, which is the point where we want to evaluate the function from, and then times the derivative of the function at that particular point. So for this problem one, we have been given that we want to evaluate the value of the function or find the error of the value of the function at x equals to 1. Error at x equals to 1 is 0.04. So therefore, epsilon a, which is error at this point, is 0.04. And then the function is given by 4x power 6 minus 5x. So what you do first, we calculate the derivative of the function. So when you differentiate this one, you get 24x power 5 minus 5. And then next thing, you evaluate the value of the function, at 1, and also the value of the derivative of the function at 1. So when you replace into the derivative for x to be 1, you get 24 raised power 5 minus 5, and then f prime at 1 is 19. So therefore, the error in the function will be the error, which is 0.04 times the derivative at point x equals to 1, 19. That gives us 0.76. Now, the next thing, we need to define the value of the function at 1, which is 4 times 1 raised power 6 minus 5 times 1, which is minus 1. And then by definition, percentage error is given by error in the function over the true value of the function times 100%. And then for this case, because the value of the function at x equals to 1 is negative, then we take the absolute value of this and then multiply by 100%. And when you simplify, you get 76%. So that's the solution to appetizer 1. Now, appetizer number 2, the function is 4 cos x plus 6x. So number 2, f of x is 4 cosine of x plus 6x. So this means that the derivative of this function will be given by negative 4 sine of x plus 6. And then which means that the value of the function at 1, at 0, because actually we want to evaluate the value at x equals to 0, will be given by 4 times cosine of 0 plus 6, and then times 0. Cos of 0 is 1, so 4 times 1 is just 4. So therefore, the true value of the function at x equals to 0 is 4. And then the derivative of the function at 0 will be given by minus 4 sine of 0 plus 6. And then sine of 0 is just 0, so minus 4 times 0 is 0. So f prime at 0, we get 6. And then you are told that the error in the function at the point x equals to 0 is 0.005. So error is 0.005. And then By definition, percentage error in the function f of x will be given by error in the function over the true value of the function multiplied by 100%. But remember, error in function of a single variable is given by error in f is error at that point times the derivative at that point. So which will be given by error at 0 and then f prime at 0. So which will be 0.005 multiplied by the derivative, which is 6. And this will be given 0.030. Because we get 5 times 6 is 30, then 3 decimal points. So that's why you have this. So this is the error of the function. So therefore, the percentage error in the function f of x will be given by 0.030. The true value of the function, we have calculated it to be 4, and then times 100%. This one, when you work it out, we have 0.030 divided by 4 times 100. So we get 0.75%. So therefore, this is the answer. One thing to note about this example too, remember that NB, this is useful, can help you to calculate errors in other functions. Whenever your function has trigonometric functions, then do all calculations, all computations when the mode of the calculator is in radians. So this is actually what should happen when you are doing any numerical computation involving both trigonometric functions and any other types of functions, say polynomials or exponential. Whenever you see any trigonometric term in the function, your calculator must always be in radians for you to get the correct answer. If the mode is not in radian, then you'll get wrong answer. So ensure that that's the first step, first thing that you need to set before you start doing the computations. So in the next presentation, we'll be doing examples on how to find errors in functions of several variables. So thank you.